Okay, we do one last sort of preparation video before we get into some real vector calculus. So that the real vector calculus will start with the gradient. But one last little subject here while we're talking derivatives and partial derivatives and chain rules. And that is taking second partial derivatives when you need to use the chain rule. And it's not as easy as what we just covered. So z is a function of the primary variables u and v, and u and v are in turn functions of the secondary variables x and y. This is just find the second derivative with respect to one of these guys, x. So the first thing you need to do is take the first derivative. So that's pretty easy. Use a chain rule like we just learned. It's going to have two terms because z is a function of two variables. Got the partial of z with respect to u and the partial of z with respect to v. And then there's the partial of u with respect to x and v with respect to x. So you want these guys to match and these guys to match. And these guys should all match this guy. Anyway, that's the first partial. The second partial, well, find it by taking the partial again of that first partial. So you already had one. It said find the second with respect to x. So we take this partial with respect to x. If it asks for the second partial with respect to x and y, this would be a y here. But anyway, so that's all we did there. And we had what partial of z with respect to x was, so we'll plug that in here, okay? Take the partial of the first partial with respect to x. And this is just a sum. So the partial of the sum is the sum of the partials. So we're down to this. It's a little bit easier. We're starting to break it down. So where were we? Well, this is just that same line. So we're here. Left off here. This is a product and this is a product. So we use the product rule. How does that work? Let's see. I'm going to have four terms altogether, but this guy is going to be first the partial of, it'll be this guy times the partial of the second term with respect to x. I've got the partial of, so I'm just taking this directly here to there. And the second term is this term's partial with respect to x. And then this guy's partial with respect to x, and then I just bring this down directly. Right now, this is just kind of bookkeeping. So it'll be this guy brought down directly times the derivative of this guy with respect to x plus this guy's derivative with respect to x times this guy directly. We just used the product rule. We didn't actually take any derivatives. Now, some of these are easy. Partial of u with respect to x. Remember, u is a function of x and y. So is v. So we can take derivatives of u and v with respect to x or y directly. No chain rule required. And the first derivative of u with respect to x or y is still a function of x or y, x and y. Same with this guy. So let's see here. Here we just broke it down into products using the product rule. So this guy, partial of u with respect to x, is a function of x and y. So we can take this derivative directly. That will just be the second derivative with respect to x. This guy will make TBD at the moment. We can't, this z's a function of u and v. Even the partial is still a function of u and v. So we can't take its derivative with respect to x directly. We're going to have to use the chain rule on this guy. And we'll defer that to the next slide. This guy's just brought down. And here again, this partial of b with respect to x is still a function of x and y. So we can take this second partial. And it's just a second partial. This guy stays the same. And here we run into the same problem. Z with respect, this partial of z with respect to v is still a function of u and v. So we can't take this partial directly. We're going to have to use the chain rule. But we've got it all down to, we need to figure out this term, and we're going to need the chain rule to do it, okay? So again, here's where we left off. Let's just look at this one term here, this second partial here. Remember, so this partial of z with respect to u is still a function of u and v. So I need to apply the chain rule again. Partial of that with respect to u times the partial of u with respect to x, plus the partial with respect to v of this thing with respect to v, and then the partial of v with respect to x. Sorry, this all just looks like hieroglyphics when you look at the whole screen, but you need to follow every step. I'm kind of doing this slowly. This was just a chain rule. Again, what you want down here at the bottom right should match what you're taking the derivative with respect to. And you want these sort of cross terms to match. U down here, U up here, V down here, V up here. And I needed as many terms as Z is a function of. It's a function of U and V, so I need 2 terms. Now I can take this derivative directly. This is a whole term. This says take the derivative of that term. This is not a term. This is an operation. This is an operation. That's a term. That's a term. Know the difference. What's a term and what's an operation on a term? So I can take this derivative because it's a function of u. So I can take it with respect to u. That's just the second derivative with respect to u. I still need this guy. And this guy, well, here, it's the derivative, it's second derivative of z with respect to u and v. Remember, it doesn't matter what order that is. And then this term just comes over directly. Then you do the same thing because I needed to take this partial as well. So it's all analogous to this. I'm still using the chain rule. Substitute these guys back in up here. And I've got all that mess. See, it's getting pretty tedious. Here's where we left off. We can start multiplying out and combining terms and simplifying, but we're done with the chain rule. We're actually done taking partial derivatives. We're just going to simplify. Everything here is a term. There is no more operations to be done. Everything was, we already took the derivatives. This du dx, or partial of u with respect to x, is the same as this guy. We'll have that guy squared. There it is, that guy squared. Look at this guy, at that. Now, partial u partial of x squared plus this guy. Multiply these two guys plus this guy directly, and then distribute this guy, and this will have a term squared. And I'm not going to go through each and everything here. Let's see. Some of these combine. Some of these are the same. And I'm just going to say you end up with this. Did it step by step. But it wasn't so easy, was it? And it was also pretty tedious. I'll do one more example. This is probably, video is probably running kind of long. Let's say I want the second partial of u with respect to t, and u is a function of, I guess I told you, u is a function of just x. X is a function of t. I didn't quite spell that out. And it doesn't tell you what the function is, but it tells you what these derivatives are. We have to go through it sort of symbolically and then plug in the numbers. So we don't have multiple, both u and then both use just a function, or yeah, use just a function of x, one variable, and x is just a function of t, one variable. But we need the chain rule. So du dt, to get the second derivative, we have to find the first derivative first. So du dt, we got to use the chain rule. Oh, and then the second derivative with respect to t, take the derivative of this guy again with respect to t. This is a product. So it'll be the first term times the derivative of the second term plus the derivative of the first term times the second. Didn't take any derivatives yet, I just applied the product. Now this guy, x is a function of t and dx dt is a function of t. So I can take this derivative directly. It's just the second derivative of x with respect to t. This du dx still a function of x. So I can't take its derivative with respect to t directly. I need to use the chain rule. Just one term. Oh yeah, I crossed that here. So this will be the derivative of this with respect to x first times dx dt. Remember, what's down here has got to match what's up there. And this term just gets brought down. No operation on this term. And here, I can take this derivative directly because u is a function of x, and I'm taking the derivative with respect to x. So this term here, just the second derivative of u with respect to x. So at this point, I've taken all the derivatives I need to and all the chain rule stuff I need to. I just plug the numbers that are given for each term. U dx was 5. The second derivative with respect to t was 4, etc. Just plug in the numbers, do the arithmetic. Sorry, that's kind of tedious, and a lot of students had trouble with. And the trick is always that, where was it? When we needed to do this and that. Got a function that's a function of u and v, and it says take the partial with respect to x. And we got to use the chain rule. Just that little term, it ends up being this. Actually, this term ends up being that. This term ends up being. If you get that part, that's the tricky or hard part. The rest of it's kind of tedious bookkeeping. Okay, with all that done, we'll get into some real vector calculus in the next video.